Hello everyone, my name is Amrendra, and in this session we will be taking a different approach, a simple approach to solve system design problems. In this approach, we will talk about how to start simple and then scale further. So, the scaling part here means not only scaling to million users, but also discussing about all the components that come into play when you design a system. So when you design a system, you always keep in mind that it can be broken into client and server model. There would be one client which will be requesting some data from the server. Server will get the request, process the request, and send the data back. So this is what we should start with. So to repeat, this is my approach. This is how I would approach and how I would solve bigger problem by taking small steps. So as you see, we have two big black boxes, client and server. Now, as an actor, as a user, you either use your mobile phone or you use a laptop or a computer to send request. So a lot is going in this box and a lot is going in this box. We will keep on dissecting each aspect and we will keep on explaining all the components that come into picture. But first, let's understand what is having at very high level. So a user opens a browser and sends a request. The request on the backend side goes to the server, backend server. Now backend server over here is one big black box. It has some code of front end running, some code of backend running on the server, and a database running. So this is all just one component to start with. We will keep on dissecting more. Now the request comes to the server. Server does some magic, does some calculations, manipulations, and sends the response back to you. When the response reaches you, it shows a beautiful page or a beautiful data that you were expecting. Now this is at a very high level. Now as a user, you type in a URL, let's say abc.com, and that URL you type in your browser or you just open a mobile application and the mobile application starts sending the request back to the backend and you get the response. But what happens when you type the URL? This URL is in human readable format, but machines talks in on the basis of IP addresses. Every machine has an individual IP address, and that is resolved by something called a DNS server. So DNS server is sitting somewhere uh, on the cloud, and it acts as a phone book. What it does is it gets a request from your mobile browser, from your browser, and looks for the IP address that is matched for this particular URL and sends back the IP address to you. So when DNS receives the abc.com, it does some lookups and sends you an IP address. That IP address is further used by your browser, is cached into your browser and used into subsequent requests for all the runs, for all the next runs. So there is a cache in your browser, and that cache stores information like these. Whenever you type in abc.com, it resolves into one of the IP address, and that IP address is further used as a URL to communicate with. Now, if you see here, it has some appended strings on the IP address. This is nothing but a URL. This is a HTTP URL, and to be precise, it has a prefix of HTTP colon double slash and IP address and your further URL. This request reaches to your server. The server again does some calculations and sends back the response. The response format I have shown over here is a JSON format, but it can be any other format also, like multimedia, text, video, audio, file, those kind of things. We will get into details more, like how do we get all those format of data. But for now, we will only talk in terms of JSON. Now, let's talk more about DNS. What does DNS do here? So we will dig deep. What does DNS actually do? So for that, I have prepared one diagram over here, and I'll explain what goes behind the scenes when a request reaches the DNS and how does it resolve to a IP address. So as I told, browser has a cache. Now when you type in abc.com, browser looks into the cache where it tries to find out the relevant IP address for that particular URL. At first it will not find anything because it has not resolved yet. So what does it do? It sends the request to the DNS resolver. Now DNS resolver has its own cache. Again, it's the same process. It looks up in the cache, and if not found, DNS resolver sends the request to the root server. The root server, there are hundreds of root server across the globe, and there are certain 12 organizations that manage these root servers. So from root server, we get the top level domain information. Top level domain is something that keeps the information about the .com or .net, uh, the URLs ending with these are segregated on the basis of the suffix. So let's say the suffix is abc.com. So top level domain server will look into the .com TLD server only. So it's kind of segregation of the top level domain. Now top level domain, as we found that it is a .com, it sends the authority IP, and authority IP is the IP for the authority server. The authority server over here keeps the information about all the domains and its respective machines. So from top level server, we found the authority server, and from authority server, we found the actual IP address. Now the actual IP address is sent back to the DNS resolver and stored in the cache. Similarly, it is sent back to the browser and stored in the cache. Now, after it is stored in the cache, simultaneously this IP address is sent, appended with the rest of the URLs, and request is formed and it is sent to the server. This is how the domain name system works. So in this part of the series where we are dissecting all the components one by one, we have dissected or we have understood what a DNS is, how a URL is resolved into IP address, and that IP address is further used as a URL. So going forward, we will unbox this particular box and we will keep on understanding each component. So to start with, we will go with the database. Thank you for watching. There will be a second part of this video where we will talk about database and then we will scale further.